Mr. Dela Cruz. So once again, good morning everyone. Before anything else, how are you feeling today? So I would like you to form a heart if you're feeling in love, a thumbs up if you are feeling fine, smile if you are blessed, ha ha if you are feeling excited, and wow if you are feeling optimistic. So before anything else, I would like to introduce myself. My name is Shayne Japitana, your calculus 2 teacher for today. So I am happy to formally meet you all. Before we will proceed to our discussion, let's check first your attendance. Miss Secretary, please kindly check the attendance of your classmates, and everyone, please say Pebble if your name is called by your secretary. Okay, wonderful! No one is absent today. Clap for yourselves, everyone! Very good! Okay, everyone, let us recall the guidelines when we will be having a class session. So here are the classroom rules. Okay, Miss Jessa, please read the rule number 1. Okay, thank you, Miss Jessa. I would like Miss Maria, please read the rule number 2. Thank you very much, Miss Maria. Please read the rule number 3, Mr. Mark. Okay, very good. The rule number 4 will be read by Miss Pearly. Yes. Okay, last and not the least, please read Mr. Pedro. Okay, very good. Okay, please be mindful of these rules for us to have an effective class discussion. So a special reminder for all, for those students that will participate in this class discussion will be given 10 points. Is it clear, students? Okay, so who can give me a brief recap on what we have discussed last meeting? Yes, Miss Salazar. Very good. So the last meeting we talked about determining definite integrals. So how many properties do we have in the definite integrals? Yes, Miss Molina, please go ahead. That's correct. So what are those properties? Yes, Miss Ederly? Okay, very good. Very good, everyone. So anyone from the class who would like to add? Yes, Miss Likanda, please proceed. Indeed, thank you so much, Miss Likanda. So anyone from the class who would like to add another? Yes, Mr. Boris. So very well said, Mr. Boris. So that was the different properties of definite integrals. So now let's proceed to our motivational activity. Who would like to be motivated? Okay, let's move forward. So first we will have an activity which is entitled to Where Did I Belong? This game, I will ask you to evaluate the choices of which of the following belongs if there are infinite limits and definite limits. So you can raise your right hand if you want to participate. Is it clear, students? Okay, the first choice is, where did population growth belong? Okay, please go ahead, Miss Jerry. Very good. Infinite limits. So another one. How about physics? Yes, Miss Desiree. Okay, very good. They are applicable to both. So in electrical engineering, where does this belong? Yes? Yes, Mr. Ezekiel Rubber?
proceed to our activity, but before anything else, may I ask everyone if you are with me? Okay, thank you so much for that response. So allow me to present our activity today. But before that, may I request everyone to read our directions. Thank you so much. Okay, thank you so much everyone again for reading our direction for today. And who wants to answer for number 1? Okay, Miss Divine. So this is for our question number 1. Okay, so yes, Miss Diane. Oh, impressive. But I want to know what is this kind of word? Yes, Jose. Very good. That's true, Mr. Jose. So, for the question number 1, the answer is infinite interval. Very good. So now let's proceed to number 2. So our number 2 is this. Who wants to answer? Yes, Mr. Pedro rather. Is that a alternate integration? Yes, L'Oreal. Let me see if that is the correct answer. Yes, Divine. Okay, very good, impressive. So for the number 2, the answer of number 2 is interval of integration. So very well said, Divine, Miss Divine. So now let's proceed to number 3. Who wants to answer for number 3? Yes, go ahead, L'Oreal. Is that the answer for number 3? Let's find out later. Yes, Mr. Thomas. Okay, very good. So that is the answer of number 3. So the answer for number 3 is integrals divergent. So now, let's move on to number 4. So the question of number 4 goes like this. Oh, sorry, this is not number 4. For the number 4, the question goes like this. So, any hand to answer number 4? I request Mr. J to answer number 4. Is that the answer of number 4? How about you, Miss Joy? Let's see if that is the answer of number 4. How about Mr. Ginser? Very impressive. So that is the answer of number 4. So the answer of number 4 is integrals convergent. So now let's proceed to number 5, the last activity for today's discussion. So we have here the number 5. So I want Miss Mangho to read the number 5 and you are going to answer it. Is that genetic? No, that's not genetic at all. So may I request from the guy who's sitting out there in the right side? Yes, you. So what is your answer in number 5? Let's see if that is correct. How about you, Miss Madi? Very impressive. That is integral. So thank you so much, guys. No. So that is for answer number 5. Very good, everyone. So you got the correct answer of the following 5 questions. So give yourself a round of applause, please. Since our activity is over, so let us try to reflect the activity that what we did a while ago with some following questions. For number 1, what did you realize while doing the activity? Okay, I want Miss Mamo to answer for the question number 1. Okay, very impressive. So for number 2, what did you gain out of the activity? Okay, yes, Mr. Kabake, you're raising your hand. Very well said. So for number 3, how or what strategy did you come up with a solution about the activity? Okay? Okay, very good. So that is the one, no? This is the one of the strategy that we need to apply about solving the activity. So for number 4, when solving the activity, does improper integrals with infinite lower limit can be relatable to our or on your real life situation? May I call Yula to answer for number 4? O sige, may I repeat? So, when solving the activity, that this proper integrals with infinite lower limit can be relatable or to your or to our real life situation. Okay, it's impressive. Very good. So that is it. So for this lesson, there are following objectives that we need to integrate this following discussion. So what are those activities? So allow me to present the objectives of the following objectives for our lesson today. So our objective today is at the end of the lesson, for 30 minutes period with 80% proficiency level, the students will be able to first is to determine the improper integrals with infinite lower limits. So that means that we are going to find what is the lower limit, define what is the importance of the lower limit, and second is to apply solving techniques or what will be the methods or strategy to evaluate improper integrals with infinite lower limits. And last but not the least, the following objectives that we need to happen is to recognize or to come up with a different real life scenarios that involve or that can be applicable to improper integrals with infinite lower limits.
What have you observed about the activity? Anyone from the class? Yes, since we already mentioned the improper integral with infinite lower limit, so what comes in your mind when you heard about it? Yes, Mr. Isnerol. Very well said. Since you already understand the improper integral, so now let's more explore on it with infinite lower limit. In this lesson, you will be able to learn more about improper integrals with infinite lower limit of a particular function. Your skill will develop upon learning and discovering new things, which is help you to enhance your mathematical capabilities to explore the new concept and ideas. So, my question is, laban or dagan? Very good, laban yun. So now, just relax, buckle your seatbelt, as together we will conquer to learn more about improper integrals with infinite lower limit. But before anything else, do you other definition of improper integrals? Yes, Mr. JM. Impressive. However, there are different kinds of integrals and most of its kind and improper integrals, but still, let's more focus in the lower limit. Yes, very good. So, to start the discussion, let's discuss different cases of integrating improper integral with infinite lower limit. So at this moment, we need to take a look at a couple of different kinds of integrals that are called improper integrals. So let's now get some definition out of improper integrals, convergent and divergent. Please read the context. Mr. JM. So based on what you have read, what is convergent and divergent? Yes, very good. When we say convergent, the limit exists. And while divergent, the limit does not exist or it is equal to infinity. Did you get it? Now, in improper integral, we have three cases. So, case 1. If definite integral f of x, where a approaches to t, exists to every t is greater than a, then it is equal to limit approaches to infinity with definite integral f of x, where a approaches to t. So, it is provided the limit exists and is infinite. If definite integral f of x, where a approaches to t, exists to every t is greater than a, then it is equal to limit approaches to infinity with definite integral f of x, where a approaches to t. So, it is provided the limit exists and is infinite. Case number 2. If definite integral f of x, where t approaches to b dx, exists for every t is less than b, then it is equal to limit t approaches to a infinity, where definite integral of f of x, t approaches to b. So, it means it provides the limit exists and infinite. So, we can see that the infinite is in the lower limit. Number 3. If definite integral of f of x, where lower limit is negative infinity approaches to c dx, and definite integral of f of x, where the lower limit is c approaches to infinity, are both convergent, then dx is equal to definite integral of f of x, where negative infinity approaches to c, plus definite integral of f of x, where c approaches to infinity, where c is any number. Note as well that this requires both of the integrals to be convergent in order for this integral to also be convergent. If either of the two integrals is divergent, so it in this integral. But for today, we have to focus on case 2. Based on this given, where is the lower infinite and upper infinite? Yes, Mr. Jesser. Yes, so the lower infinite is infinity. And the upper infinite is, yes, the b. So, now, let's proceed to our first example.
Okay, now let's have an example. So let's evaluate the okay, so let's evaluate. First, this is the definite integral of dx over 4 minus x squared, where negative infinity approaches to 2. So first, let's have a u substitution. For u, what will be our u? Okay, very good. U is equal to 4 minus x. So the derivative of u will be what? Derivative of 4 is, very good, 0. How about derivative of x? Okay, 1. So therefore, we have a derivative of u. Let's substitute the u using let's substitute the 4 minus x using u. So, this will be 2 du over u. Is it only u or u squared? Very good, u squared, because in our example, in our given integrals, it is squared. So, then du. Okay, next one is this will be our u substitution. It will be definite integral of du over u squared, where negative 1. Therefore, we will put here the dx, which is, substitute the dx, which is du over negative 1. Okay, let's cancel. This will become 2, negative 8. So what will happen to du? It will become, again, come again, it will be cancelled. Yes, it will be cancelled, therefore. So what will happen to du? Okay, it will be cancelled. And how about the negative? Let's remain the negative. Let's put it here. And yes, u squared. How do we integrate u squared? Come again. How do we integrate the u squared? Okay, let's go back to the basics where the negative times the definite integral of u will be, okay, very good, u 2 plus 1 over 2 plus 1. Therefore, negative times the definite integral of u raised to 3 over 3, where 2 is negative infinite approaches to 2. Okay, so we already have the dx. Let's substitute. We already substitute the dx here. So what will happen to du, which is our numerator? It will become cancelled. So how about the negative here in our denominator of the dx? So we will multiply the negative for overall solution to. Okay, so this will become 1 over u. So u squared rather. So we can have so in order to find the solution, let's transfer the denominator to the numerator. So what will happen if you transfer u squared as our denominator? Yes, Mr. Jesser? Very good, once again. So it will become negative times the definite integral where negative infinity approaches to 2. It will become u raised to negative 2 since it will become it will become our numerator. Then after that, what will happen? Okay, let's go back to the basics. Negative times the definite integral of where negative infinity approaches to 2. Okay, let's go back to the basics. Negative times the definite integral where negative infinity approaches to 2, it will become u raised to negative 2. What will happen? Yes, you will add 1. Then, over, what will happen? Okay, the denominator will become negative 2 plus 1. Very good, students. So, after this, what will happen? Okay, let's add negative 2 plus 1 and the denominator negative 2 plus 1 will become negative times 2 u raised to 1 over 1. Since it is already over 1, let's remove this because every integers have an imaginary denominator of 1.
Negative 1 na siya. Yung negative 1.
Cancel. Okay? Since we have negative 1 as our denominator, we will cancel it because we have a negative here. Cancel. It will become 2 a negative infinity approaches to 2 u raised to negative 1. Okay. Let me proceed to the next next space. Okay, next part, since we already have here, it will become x approaches to 2. Then subtract it with 1 over 4 minus x, where x approaches to negative infinity. Okay, let's substitute now. First is 1 over 4 minus, what is our x? 2. Minus 1 over 4 minus 2. Again, the negative infinity. It will become 1/2 minus 1 over 4 times infinity. So, since this is an indeterminate form, what is the rule again? Yes, if the denominator is infinity, it will become, okay, it will become 0. Therefore, 1/2 minus 0 is 1/2. Very good. So, what does this mean? It is a conversion. Very good. Do you have any questions? Does everyone understand? Okay, any clarifications? Violent reactions? Okay, good question. We let 4 minus x argue in order to integrate the problem. Is it clear, anyone? Everyone, is it clear now? Okay, now let's have another example. Okay, is it clear now? Okay, so let's have another example. For this one, please get one whole sheet of paper and solve it on your seat. So I'll be giving you 10 minutes to solve the equation, and after that, I will call someone to present the solution. So evaluate this. Okay, so evaluate the definite integral of x over x squared plus 1 dx, where negative 8 approaches to 0. So who wants to volunteer for this to answer this function? Okay, how about okay, Miss Sarah, how about you kindly present your solution and explain afterwards. Okay. Okay, very good, Miss Sarah. So she come up with the solution which results to negative infinity, which is a divergent. Okay, very good. So do you want another example? Okay, solve this on your paper. Okay, solve this where definite integral of e raised to x raised to negative 4x, where negative 8 approaches to 0. Okay, solve this in your seat, and I'll be giving you another 10 minutes to complete the solution. Then another 10 points if you are doing it silently, and 10 points for those who can present me the solution with complete and right answer. So is it clear? Okay. So are you done now? Very good. Okay. So are you done now? Okay, so since you're all solving and exerting your efforts, for the efforts I will give everyone 10 points each for doing it silently. Very good. Your solutions while I roam around is very convincing since you already get it. A round of applause for yourselves, please. Very good, students.
students.
To sum up, first, we need to recall that we can't do the integral as long as there is an infinite in one of the limits. Therefore, we'll need to eliminate the infinite first as follows. Note that in this step, really needed for this integral, for some integrals, we can use basic logic and evaluate at infinity to get the answer. However, many of these kinds of improper integrals can't be done that way. This is only way to make sure we can deal with the infinite limit in those cases. Next, let's do the integral. Well, not be putting a lot of explanation, details into the integration process. By this point, it's assumed that your integration skills are getting pretty good. If you find your integration skills are a little rusty, you should go back and do some practice problems from the appropriate earlier sections. Note that we don't do the definite integrals here. The limits don't really affect how we do the integrals and how we should help in dealing with them until the next step. So, yes, okay. Now, let's take care of the limits on the integral. So, even if it ends up being one of the integrals in which we can evaluate at infinity, we need to be in the habit of doing this to those that can't be done that way. We now need to evaluate the limit in our answer from the previous step here in the limit work. Is it everything clear? Do you get the process of integrating improper integrals with infinite lower limit? So yes, very good.
So now let's have our evaluation for the discussion, the lesson that we discussed today. So now let's have a group activity. So the title of our group activity is all about Together We Share. So let's have our instruction. Every group shall create a situational problem related to improper integrals with infinite lower limit. So the teacher will give the list of the group. So I will give you the list later on so that you can proceed to your activity. And the performance will be graded based on the criteria. So we have here the content, which is 15 points. Organization, we have 10 points. Cooperation, we have also here 10 points. Creativity, we have 5 points. Timeliness, we have also the 5 points. And overall, we have 50 points in total. So, for this case, you have one presenter going to present the problem and involving the case 2 for the improper integral. So, as what I said a while ago, that you are going to evaluate or making it the problem, situational problem relate to the improper integrals with infinite lower limit rather. So make 2 equation, situational equation per group, and make sure that everyone is collaborating because we have here the criteria for cooperation, which is 10 points. And make sure that everyone, as well as I said, cooperation to avoid deduction of points. And did I make myself clear? And okay, thank you so much for that, And you will present this activity next meeting during our class hours. So I guess that we will conclude our discussion today. Any clarification? Violent action? Okay, so I guess not, no? So, okay, thank you so much guys for listening to our discussion today and also your active participation. I hope that you can learn something for our discussion throughout this day. And again, be safe and class dismissed. Thank you.